Hi, today is Friday, April 3rd. We are on Module 6, Lesson 10. Our objective for this math lesson is to use square tiles to compose a rectangle and relate to the array model. For this lesson, it's going to be really important that you have some sort of material that you can move around to create your arrays with. If you don't have square counters or square blocks or tiles, that's fine. Use whatever you have. You could use dried beans, you could use Cheerios, you could use fruit snacks, whatever you have that's small and can be easily moved around to create different models of what we're doing in math. For our example today, I'm going to cut my board in half. And I'm going to do two problems side by side. And I'm going to look at how some things about my array models are similar and how some things are different. For each example, I'm going to need 10 tiles. So I'm going to need a total of 20 tiles or counters all together. So go ahead and count out 20 of whatever it is you are going to use to solve these problems with me, and then we'll get started. On our first side, we are going to come up with 2 rows of 5. I'm going to go ahead and move my counters now to show 2 rows of 5. So I have 1 row of 5. And I have 2 rows of 5. And just below it, I'm going to write 2 rows of 5. Now with my 2 rows of 5, I want to be able to figure out the total of how many counters there are in the array altogether. So I'm going to write a repeated addition sentence. I can see in the first row that there are 5 counters, 1, 2, 3, 4, 5. Plus, in the second row, there are 5 counters, 1, 2, 3, 4, 5. If I count them all up, I know my doubles fact, 5 plus 5, I know that these 2 rows of 5 make a total of 10 counters all together. Now I'm going to leave this example here and I'm going to move to the other side of my board for part 2. That way I still have part 1 to compare and contrast when I'm finished. For this one, I'm going to create 2 columns of 5. So go ahead and do that as I do mine. 2 columns of 5. Here is 1 column of 5. And there is my second column of 5. Below it, I'm going to include what kind of array I made, which was 2 columns of 5. Now you might already be noticing similarities and differences between our arrays, and we're going to get to that in just a second. But first, I want to solve for the total number of counters in this array. Looking at my first column, 1, 2, 3, 4, 5. And looking at my second column, 1, 2, 3, 4, 5. That leaves me with a repeated addition sentence of 5 plus 5, and again, I know that makes a total of 10. Now, some things that are similar about my 2 examples is that my repeated addition sentences were the same. In both examples, I came up with 5 plus 5 for a total of 10. I used the same amount of counters, but I created 2 different models. Something that's different about my examples is that in my first one, I was looking at rows, and in my second example, I was looking at columns. Today, when you move to your math workbook pages, you're going to be given some directions on different arrays to create with your counters. If you don't have counters, you could draw a picture. What you're going to notice is that some of these arrays have similarities, things that are the same about them, and things that are different. You might be encouraged to create an array looking at the rows, or you might be encouraged to create an array looking at the columns. I really encourage you, as you're working through those examples in your math workbook, to think, how else could I use my counters, the same amount of counters, to create a different array? Would my repeated addition sentence stay the same, or would it be different? I'm going to go ahead and move on to our daily word problem now, so I'm going to clear my examples and get ready to share that with you. My word problem today says Giada's toy telephone has buttons arranged in 3 columns and 4 rows. I'm going to stop right there first because there's some information here that's important for me to figure out. First, I know that there are 3 columns, and I know that there are 4 rows. It doesn't tell me how many are in each column or each row. So this one's going to be best solved by using something you can move around. You're going to have to experiment and explore with your materials a little bit to see if you can come up with how Giada's toy telephone looks with the buttons. Part A says, draw a picture of Giada's telephone. I'm going to use my manipulatives to see if I can come up with an array that would match the arrangement Giada's looking at. I know she has 3 columns. So I'm going to start here. This is going to be a column, this is going to be a column, and this is going to be a column. And I'm going to add on to it until I have 4 rows. I have 3 columns, but I only have 2 rows, so I can't be done yet. I'm going to keep adding on. I have the 3 columns, but I only have 3 rows, so I'm not done. Now I have 3 columns and I have 4 rows, so I can go ahead and stop because I've made the array that Giada sees when she's looking at her toy telephone. Part B says, write a repeated addition equation to show the total number of buttons on Giada's telephone. I'm going to do my repeated addition sentence by looking at the rows, but you could also add this up by looking at the columns. So if you want to try columns while I try rows, you can, or you can try rows along with me. Looking at the first row, I see 3 buttons, plus the second row has 3 buttons, plus the third row has 3 buttons, plus the fourth row has 3 buttons. 3 plus 3 plus 3 plus 3 is my repeated addition sentence for this word problem for a total of 12. And I need to write my answer back into a statement to explain what it means. 12 is the total number of buttons Giada has on her toy telephone. My sentence is going to be Giada's telephone has 12 buttons. Thanks for checking in today for Module 6, Lesson 10. I hope you found this helpful. When you move into your math workbook, don't forget to get some things you can move around as manipulatives to create those arrays as you're working through those problems. See you later.